Hello and welcome back to Compiler Programming. Today I'm gonna work on literals or immediates or whatever else we can call this. It's gonna be probably quite a lengthy video, so strap in. I'm gonna start, I think, with a refactoring of how immediates are handled in the here. So immediate is the only type where you have sort of uh, size as a part of the type, and it was convenient to match it closer to what the CPU supports. But first of all, different kinds of CPUs will have different support for these sizes. So I believe on ARM it's not possible to do 64. It might not even be possible to do 32-bit immediates. So that's kind of something to consider. And I think what I want to do here is to get rid of the size here and do something else instead. And that something else would be to have sort of a pack storage for an immediate, and that storage can either be inline inside of the operand, or it can point to a read-only segment, which we actually don't have. So for now, I think I will put it in the regular data segment, and this is where the things will be stored. I think that is the plan. But obviously things can change on the way, so let's try it out. Let's start with this immediate refactoring. I have no idea what the implications of this will be, but the idea is that we will remove this stuff, and I guess in here what I will do is I will say that actually we probably will need a new type, which is also a union. How would that look like? So let's start with that new type. Won't have common fields. I don't think so. Yes, and that will be, we'll call it immediate. An immediate can be inline, I guess, or small, or large. I don't know if these are even good names. Let's put it here, small or large. And the idea is that a small immediate is will have bit sizes from 0 to 64-bit. So we will just store it in line in this object or in this struct. And then large ones will point to that data segment. Okay, small, bit size, actually, I do 8, it doesn't really matter. Bit size, maybe I do want to have common fields after all. Let's do that. Immediate, and then like this, and like so. Honestly, we don't even need this bit size because it will be on the outer thing. I also need to change this to a bit size to do change to bit size. We might do it in this video, we might do it later, I don't know. So actually, no, we don't need this after all, which is good. Small and large. And here I will just say U8 um, I guess you ate 8 storage. Oh, memory, I don't know. And here it will be probably a label, I guess. I mean, if it is, if we want it to be an immediate, I guess no, I guess immediate will not be stored in data segment automatically, but rather when we make use of them and or need to take an address of it. I wonder if I want to not do this optimization on the small one. Yeah, let's ignore the small one for now. Instead, this will be U8 star bytes, and the size will come from here. So maybe it would be nicer to just put this slice into here, but slice is dealing with bytes, and we might want to deal with bits. So here we might say, let's call it inline maybe, and there is going to be another one that is constant data maybe, and constant data, well, constant data should just become this one, should become a label operand. So maybe we will just leave it as like this. U8 star byte. Okay, that obviously creates a lot of issues, but we can take a look at them and try to do them one by one. Okay, here it's pretty straightforward with a tag, we just remove it, but it won't be that straightforward with this part, because we will need to store that somewhere, but I will not deal with it right now. And here as well. So we'll need to switch on the size here, I guess. Okay, first of all, I don't like that I have this repeated. So let's deal with that first. Wait, token handle negation. And we will take this stuff, put this here, and I will say token handle negation. It probably needs context, it needs a token. Okay. Counts token star token. There is no stack in here. Context, yeah. Return new token. Let's try that. Cannot convert from void to token. Yeah, that's because this should be const token star. Okay, that seems fine. Let's update it here as well. So like so. I guess that looks fine. Okay, what is that? This deals with comparisons. If right hand side is an unsigned integer and left hand side is a signed one, and then what do we do? Okay, we basically cast it, sort of. Yeah, we copy the value and we cast the signedness of it if it fits. I'm not a huge fan of how it ended up being. I think the whole thing with integers and literal integers will need to be redone as well, but this is separate from what we're doing right now. Right now we are talking about how we are storing and presenting them in the program, and this is more about semantics and conversion rules. I think I will need to say something like operand immediate as u8 like so, and we can go into here, and here's operand immediate. So we already have this as, right? And I will need to maybe turn this let's do a macro. Operand immediate cast. Do I want to just keep it as a macro? No, I think I want to make it into a bunch of functions. So it will get the type. It will put the type in here. And it will return the type. Right? And that will get what will it will be const operand star operand, and it will do the following. It will say that well, I will actually assert in here and say that operand byte size is equal to size of whatever type we passed in here, and then it will return star well, let's also make it static inline. Return star of operand immediate bytes. And here we will cast this to type star. Maybe here I actually want to make it a void star, because I'm really don't know what I'm pointing to here. Like it can be literally anything. So let's not call it bytes, let's call it memory. Okay, and operand immediate cast of U8 of S8 16, 16, 32, 32, 64 and 64. This one will actually need to be, this will break in a bunch of places because we expect it to be sort of used as I would just want a number, and instead I like previously we would always cast up to S64 here, but now that's not going to happen. Right now you expect it to know exactly what is the size of this. So maybe I want to change the name of it and call it operand immediate, I don't know, memory as type, just so that I can remove this one and have the compiler error on unknown function and be angry at us about that. Okay, operand is immediate. Let's remove that as well and replace it. Maybe actually for now I will just say like this, and later I will replace this function. But maybe it's fine. Okay, operand equal. That is will be now like this. If a byte size, actually this is already happening here, so in here we can just do directly mem compare. So mem cmp of a immediate memory b immediate memory, and the size here will be a byte size. So that's easier to deal with. What's next here? Value from U64 internal. Okay. So tag is like this, and memory is so I guess I need to do it like this. U8 star bytes is yeah, there's gonna be quite a big change. This I'll have to say about that, but it's fine. Let's continue chipping away at this. The reason I'm looking around right now is I'm thinking now might be a good time to actually turn this into a macro as well. Or alternatively, let's do the following. Let's just comment this all out and then see where we are going from there. Okay, immediate, that's fine. Now it's gonna be immediate and then percent LLU operand byte size. Immediate. Actually, no. I do want all of these. So now it's gonna be like switch of brand byte size. Case 1 is 8. Something like this, I guess. So for now, let's just do panic unsupported immediate size when printing. Okay. And this was actually immediate 8. This was correct. We don't need this after all. Let's get this one and this one. Remove these guys and get this stuff out here. So you're U16, you're U32, and you're 64. Maybe I should be using those cast functions that I created. I guess I should. Operand immediate as U8 of operand. U64, U32. Guess they're called memory now. 16, U32, U64. Okay, is that any better? You don't know these functions. That is because they're defined way too low. That's something we can fix. Okay, case 4 already exists. That should be case 8. That's great. Okay, these things create immediate values. Well, let's do the same thing. We will just remove these for now from here. And then deal with it. Okay, value from S32 internal. Okay. Let's remove this one as well for now. See function value. Okay, you want an immediate 64. For now, I will leave this in here as well. Memory is U16. Memory is U32 and memory is U64. I guess I need to have this stuff here. I'm missing a parenthesis. Actually, two of them, apparently. And another one here. Okay, that at least does not explode during compilation. Okay. So this stuff, it extracts the value out from compile time execution. I'll need to think about it for a second. Here, yeah. So we definitely need a way to create immediates now. That's fine. Guess let's make that happen. So that was somewhere here. Immediate 64. Okay. Here's actually how I'm going to do it. So I still want to have this small buffer, U8, 16, small buffer. And what I'm gonna do is, if the value is small, I'm gonna put it into here, and I'm just gonna point memory into this one. So this way, it's okay for all C users. They can just always look at the memory. You don't need to use a getter or anything to switch between different implementations, and you're just gonna get this memory. It's not as memory efficient as it could have been, but I think that is actually pretty decent way to do it. So let's make that happen. Okay. It's a bit awkward to create it as a literal because you're sort of actually no, yeah, you can't do it. No, I'm doing the wrong thing. You can do it because you're gonna copy this around and it's not gonna work. Okay, whatever. It's fine. It's fine. I guess I will need to change all of this stuff to get an allocator because it will need to allocate the memory. A const allocator, const operand, that's fine. Okay. I think it should actually get unsigned ones now. So define operand immediate structure or something. It also gets whatever. Let's do it in line first. Okay, so memory. Is gonna be a very funky thing. We'll do mem copy to allocator allocate bytes, Actually, no, allocator u8. So we are getting it from value and size of value. Something like that. Okay, let's for now copy paste this into here. U64, U32, U16. Let's put this in here. That will help when I turn this into a macro later on, but also it helps avoid copy pasting mistakes. So because right now we only have it in here, and I guess I want to do allocate bytes, size of value, size of value. That's actually means that the implementation of all of them is exactly the same. Now they're missing the allocator, which we can add here. So this will also need an allocator. Let's leave it like this. I'm not exactly sure that the cuts here will be totally fine, but let's see. The whole story behind this and sign this is a bit shaky right now, but it's going to get better. Okay. Getting back to here, we are gonna do immediate age of context allocator integer or s8 of integer. Here's s16, s32, 32, 16, and finally 64. Looks correct to me. Now the same thing needs to happen in here, except that it is U64, U16, and U8. Okay, that is better. Here we are negating this stuff. Okay. Let's do it as follows. Switch on value operands byte size. And the same stuff. We need 1, 2, 4, and default. Terminal error, unexpected integer immediate size. Okay. And again, 8, 4, 2. And now we're gonna do value. Operand is immediate 8 of minus operand immediate memory SS8 and value operand. Something like that. 16, 16, 32, 32, and 64, 64. And we also need context allocator here. Okay, so this is this stuff. What's happening here? So here we are, we are basically just copying the memory out of the result, to be honest, right? And we have result as a pointer. Yeah. So honestly, we don't need any of that. We can just say, where is a result allocated? Result. Where are you? Yeah, allocator, allocate bytes. That seems perfectly fine. I can say token value operand is, and I will have to construct it manually here, but that's fine. Operand tag is operand tag immediate. I don't even need to do it for only integers, as long as it's in the pack value. And this is where we start to hopefully get this benefit of common epoch value rather than just dealing with integers or floats directly. Parent tag immediate. Byte size is, and finally immediate memory is result. So technically that should work, but you never know if that's the case. For now, I guess I will comment this out because I'm not 100% sure that this is the right thing to do, but we will see. Anyway, that's it for this file. We have everything done here as well. I think we have a bunch of problems in here. Not as many as I would think we will. So here the only problem is that we need compilation context, and then context program. Okay, and then we need to pass context allocator into here. And context program into there. Okay, that wasn't too bad. Basically the same thing here. Program star program is context program. Hope this works out. Push instructions. The same thing basically. It's a bit of a silly thing to pass allocator to for just 1 byte, but I will fix that separately. It's definitely not important for the functionality. It's only going to be important for the speed later on. Okay, who is next? Well, next, I guess, is encoding stuff, and it makes sense. But for encoding, it should be actually much easier. We can just do, if it's an immediate, then we append the slice, and we just say slice, or let's do it like this. Slice is bytes is operand immediate memory, and then length is operand byte size. This is all we do. We just append this stuff, which should be easier. Okay. That even seems about it in this file. Who is next? Next is we are back to function.c. We have a value from S8, S16, and S64. Okay. And there is this operand immediate as S64. So somewhere, let's start this thing. Okay. Same validate. Okay, this just checks for 0. Hmm. I guess I can leave this as it was. Sort of. So we would have it accept the const operand star operand, and I would do assert operand. Actually, no, here it doesn't matter. I can't really assert what I want. All I can do is say switch of operand byte size, and same case 1, return operand immediate memory as S8 of operand, and we don't need to cast it to a 64 explicitly because C will do that for us. Default break return 0 panic unsupported integer immediate size 64 32 16 sounds reasonable. Okay, get more errors. This should be const. This should be const. So here we have value from that is missing. Yeah, all the value stuff needs to be fixed now. Value from. Let's uncomment that and see what we are dealing with. Well, we just need to pass allocator into here, to here, to here, and into here. This should just be immediate 64 of allocator and integer 32 16 and 8. Okay, we are almost there. Let's see what's going on here. So it is immediate. We need to check that the status operand byte size is 1, and then we can do operand immediate memory as S8. Is 42. Is it any better? It is. So let's copy it here. Let's remove this stuff. Okay, what else is happening? Function encode. We need to change its type. Because now this is a compilation context. And the same thing for make trampoline, I guess. Yep. And we just need to pass in the correct thing. Do I have the context here? I do. It's great. And the last one, I guess I need to do the same thing. Program step program is text program. Compilation context. Huh. I don't actually have it. Well, it's fine. I can pass it in here. More stuff. Okay. Almost there. And we are done. Well, moment of truth. I doubt this will actually work for this time, but you never know. Maybe it will. And of course, it does not. Okay. So what is happening here? This is a function spec. So this is this thing. And should use a temp register for immediate memory move. Instruction equal. Instruction equal. That's an interesting one. What are you doing? So you are. Let's open this up and actually take a look at this test. Because I'm not sure exactly what's going on. I think it has to do with the difference in how we encode things now, but it's not clear. Operand equal. I mean, that seems correct as far as this goes. Yeah, not sure, not sure. Let's change these to be function spec and function spec. Which one is the first one that failed? Temp register for immediate 64 move. Okay, let's run this. So we need to look at instructions. Which locals, builder, code block, instructions, data, items, add watch. Let's see what's going on. So we have two operands. That seems actually two instructions. Sorry. And assembly operands, two operands, a register one, and an immediate. Immediate's byte size is 8. And that seems correct. Okay, what about this one? The original immediate operand tag immediate. Yeah, that seems fine as well. Memory. So maybe I should actually mark it as S8, or maybe not, I don't know. If I do mark it as S8, then it will be easier to debug here. Well, let's look at it. And watch star. So it's a long star. Is this correct? Okay, so the value is actually correct in there. How about the value in here? Well, let's just step into it and see what's going on. It's fine. Have instruction, it's assembly, they have the same mnemonic. We go into operands, they are registered, they are the same. Everything is fine. Now we go into immediate and they have the same byte size. So that's good. Well, I assume that this call fails. So let's add watch and star, long star. Well, they are the same. Okay. Yeah, I'm slightly stupid because they should be like this, because memCompare returns 0 if they are equal, right? I think. So let's try that again. Well, that's much better. So we passed all the function tests, and now we have a failure there. Okay, let's switch this back to source spec and just run it and see where we fail. So we fail inside of the macro, which are always fun to debug, but we have here operand immediate as U64. Okay. And which test is that? So I assume it is x more than 0. Okay. Interesting. So the thing is, yeah, right hand side is actually the wrong size. So this is U8. U8 fits into S8. U64 fits into... Yeah, that's kind of a bit awkward thing that we have to do here. I guess I want a second function where I basically do this kind of thing. maybe. Well, it built. Let's see if that helps though. It doesn't seem to help much, even though I thought it would. We are still here. We're still in dispatch operator. And it just says that right hand side value is not the right byte size. Okay. I haven't actually done the right thing. This needs to be this. I probably should rename it to something more explicit, like up to U64 or something. Okay, so that is amazing. That is basically the end of refactoring. This took way longer than I expected, but I warned you that this is going to be quite a lengthy video. We say 132. Use add arbitrary sized immediates. Okay. Now, what do we do next? Well, I guess next is to actually try to use it for something else other than integers. And this might be a bit tricky, but we can try. I think the only candidate I have in mind right now is we also have floats, maybe. And let's see how they're done right now. I think right now I explicitly have value from F32. Yes, I have these explicit things that basically just get the pointer and to the global data. So what if I get rid of you for a second? Well, apparently nothing happens because I'm not using them. That is good to know. Okay, what is next then? I'm not even sure. The next thing will be probably strings. Let's take a quick look at that, but it might be a bit too much to stuff into this video, so I'll think if I want to deal with that at the moment. So token string, 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 that's fine. Good. Okay, so this is where we turn a token into a string. And right now, it happens like this. We get the bytes and just create a C style string from it and use that. I think string has to be a separate video because there is a whole thing about how we represent them, how we deal with them, and what are we going to do in the long term. So I guess that would be all for today. I thought I would be a more feature stream, but then being mostly a refactoring stream, and I'm okay with that. There is always tomorrow, and there's always going to be next day. So that is going to be it for today. thank you very much for watching, and hopefully see you next time.